Hello, this is Dr. Dominic White from George Mason University. In this video we are going to discuss the different uses of models and how our intended use affects the process of creating the model. There are generally two reasons why we might want to create a statistical model of some data. The first reason, and this is the reason we have concerned ourselves with so far in the course, the first reason is to understand our data and explain the relationships between different variables. We often like linear models for this purpose, because they are simple and easy to interpret. The contribution of each variable is its slope, or coefficient. It's hard to get much simpler than that. When we assess the model's suitability, we are concerned with how well it explains the variation in the data, and whether it is different from a null hypothesis of no effect, and so we often turn to our statistical inference toolbox to do so. But there's another use of models: making predictions. A model tells us how one variable depends on other variables, and so we can use it to predict further values of that first variable. When we model for prediction, we generally have a different set of concerns. Now we are less worried about statistical significance, or whether we can understand the model and use it to make sense of the world around us. Instead, we are almost solely concerned with how accurate the predictions are. If you are trying to predict the stock market, you don't care too much about whether your model can explain the inner workings of the financial system, only whether you can accurately predict the price of stocks tomorrow and the day after that. Now, as I have hinted at, there are many different ways we can create models. You are familiar with linear regression, where we predict a continuous response variable as a linear combination of one or more explanatory variables. But there are many alternatives. You don't have to worry too much about this list. I have put it here mainly to illustrate the diversity of options. However, we can break down most models into two categories: regression models, which predict a continuous value, and classification models, which make categorical predictions. The process of creating models for prediction is often called machine learning. It grew out of computer science rather than statistics, so although there is a lot of overlap between machine learning and statistics, the two fields use different names to refer to some of the same things. For example, explanatory variables from statistics are usually called predictor variables or features in machine learning. There are a handful of names for the response variable, but the target variable is one of the more common, although you'll sometimes see it referred to as the labels of the data. And when we create a model and try to find the optimal parameters, such as the slope of the line of the best fit, we say that we are fitting a model to the data, or learning from the data.